All right, this lesson is about the situations where we will have variable demand instead of constant demand. And of course, variable demand is a situation that is completely typical, very seldom do stores or processes know exactly what the demand, particularly the external demand, is going to be, or the independent demand. So we're going to talk about those particular situations, and there's going to be two different cases that we're going to look at, one in this video and then another case in the next video. So let's start to look at that. Again, as you know, the EOQ model and PQM models assume that everything is precisely known at every point in time. And of course, that's not exactly what happens. And so we're going to consider the two different cases. Number one, which is the the continuous review inventory system. And then in the next video, we'll consider the periodic review inventory system. And so that's today, or this particular video, we're going to look at the continuous review system, where we do have information systems in place, and even though the demand is variable, we'll know at any point in time what inventory is on hand. And so here's what this looks like. Remember, the only thing we're changing is that the demand is variable. Everything else remains the same as with the EOQ model. The lead time is constant. There's instantaneous resupply of 100% of what we ordered. The only thing that we don't know is the demand. And that's shown in this graph. Remember, in our EOQ model, it's a sawtooth model with instantaneous resupply and then linear depletion until we reach zero. Well, in this situation, the demand is variable, and that's shown by these stepwise. And you can see, for example, here that demand in this period of time is very small, whereas in this period of time, from here to here, there's a great deal of demand. So it's definitely not constant. And so we roll along, and in the first period, we reach our reorder point. We place our order, and then in that fixed lead time, we get our resupply at this point. And in fact, we have inventory that's actually remaining at this point in time. But in the next cycle, when we place our lead or our order when we reach our reorder point, this case, we actually have demand that we cannot fill, and this is called a stock out. And of course, that's not a good situation for anyone, because you can't fill your demand. Your customers are angry, they walk away. Or maybe if you're in a manufacturing process and this is your supply line, then part of your supply line, then perhaps your manufacturing process is harmed. So we want to remedy that situation. So the way that we do that is we add what's called a safety stock. And the safety stock is a buffer that we add to our on-hand inventory, so that we have sufficient quantities on hand during this lead time. And so we do that because demand is variable. We have to express this in terms of probability, and we want to have set a probability that we will meet the demand during that lead time. So the service level is expressed as that probability. It's either the probability that there's no stock out, or the probability that the demand during the lead time is less than or equal to the reorder point quantity. And you'll hear it most often expressed as the probability of no stockout. So if we say we want a service level of 95%, for example, that means that's the probability that we will have no stockout, or the probability that our amount on hand will meet all the demand. So the management expresses this service level at what risk they're willing to accept that there will not be a stockout. Again, the higher service level, the less risk management's willing to accept. And the way this is done is we're going to actually need to calculate a reorder point that includes a designated amount of the safety stock, and that's this area in green here. This is the safety stock that we need to add to this reorder point. And so in that situation that we had before, in that second cycle, instead of not having inventory on hand, now in the second cycle, our safety stock allows us to fill that inventory and continue to operate and continue to meet our customers' demands. There still could be a situation where this demand still might lead to a stockout, but the probability is so small that the management is willing to accept that small probability that a stockout could occur. So now the question is, how do we calculate that? How do we determine now this reorder point that incorporates the safety stock? And we're going to consider this as the follows. We're going to consider that the demand has a normal distribution. The lead time demand, D is going to be our D bar is going to be our average daily demand, and that the demand has a normal distribution, and the parameters are the mean is D bar, the average daily demand. Even though it's a variable, we can still calculate what is the average daily demand. Average demand. And then our variance is going to be called sigma. The variance is going to be sigma squared sub D, or it's the variance of the demand, or the sigma D, which is the standard deviation of the demand. Okay, so the demand has a normal distribution, which is why we have the bell-shaped curve. So from this lead time demand, we're going to add this amount of safety stock, which is our Z value that's associated with our service level, times sigma sub D times the square root of the lead time. If we were in a math statistics class, we would derive this. It's not terribly hard, but this level here, based on those parameters, is our safety stock. Okay. So now here's the summary of what we need to know. And again, for our continuous review model, we're calculating the reorder point, not the order quantity, but the reorder point, R. And we're going to do this by, here's our lead time demand, D bar times that lead time, plus our safety stock. And that's going to be equal to our reorder point. And that's all described further on page 567. Again, D bar is the average daily demand. L is the lead time that's known and constant, standard deviation of the daily demand, and Z is the number of standard deviations corresponding to the desired service level. All right. Let's look at an example. This is an example number 13.6 on page 568 of the textbook. And let me read it to you. It's the ePaint Internet Store. And so for the ePaint Internet Store, we will assume that daily demand for iron coat paint is normally distributed with an average daily demand of 30 gallons and a standard deviation of 5 gallons per day. The lead time for receiving a new order of paint is 10 days. Determine the reorder point and the safety stock if the store wants a service level of 95%. That is, the probability of a stock out is only 5%. So let's take a look at that. We're given everything in this problem except the Z value. So let's record everything and then make sure that we understand. We know that our average daily demand is in the problem. No, I'm going to get a different color. The average daily demand is 30 gallons per day. We'll abbreviate that, gallons per day. Our standard deviation of that demand is 5 gallons per day. Our lead time is 2 days. So in order to calculate the reorder point, again, the reorder point is D bar times the lead time plus Z value, which we haven't determined yet, times 5 gallons, or times sigma sub D times the square root of the lead time. And we can begin to substitute these in. This is 30 times 10. So without safety stock, our reorder point is at 300 gallons. And then we add our safety stock, which is Z times, and this is a Z, not 2, Z times 5 times the square root of 10. So the only question that we have left is to determine is what's Z. Now I'm going to go to the we know that our safety stock is service level is 95%, and so we're going to use our table of normal distribution to determine what that 95% level. And again, this is, you may remember, you will remember hopefully, this is a one-tailed test. So we want to find the point, the Z value that corresponds to the fact that there's 95% under the curve to the left of this point. So that's what we want to determine. So let's go to our chart. And again, we're going to look for the value of 95% probability in the table. Here's 0.94, 9525, 9505, and 9495. And again, we will want to choose the larger in this case. This is slightly more than 95%, which guarantees at least 95%. If we choose 94.95, even though that's very close to 95%, it doesn't guarantee exactly or at least 95% service level. So in this case, we want to choose the Z value that corresponds to 0.9505. In reading our table, that's 0.16, and then up 0.165. So our Z value is 1.65, and that corresponds to the 95%. I'm going to abbreviate service level. Okay. Now we're going to go complete our calculations and go back. Again, this is what the work that we've done previously, and we knew everything in our formula except our Z value. And as we substitute in, we'll see that our reorder point is in fact 326.1 gallons. And if we wanted to know what our safety stock is, our safety stock is just this component of the equation. And so the safety stock for this problem is situation example is 26.1 gallons. Again, continuous review model, and for variable demand, we are calculating a reorder point, which is going to be different from when we see our periodic review inventory model in the next video. As always, if you have questions, don't hesitate to ask.